Okay, so good morning, everyone. Welcome to the LinkUp. This is my inaugural virtual conference for girls and women in STEM. We're going to give people a few more minutes, but I just wanted to introduce it while we're waiting so that we don't take up too much of our panelists' time. So today at the LinkUp, the theme is to see it is to be it. Because the most important thing for young girls, especially those of color, is to see successful women that look like them in their dream fields so that they know that it is possible for you to be in all these different STEM fields, like engineering, robotics, which is our panelists for today. And I would just like to also start off by thanking my grandfather, the late Kameron, for giving me my first screwdriver. And that was kind of my introduction into the tech and engineering world. And also to my mom, my sweetie, for encouraging me, supporting me, sacrificing for me, and boosting my curiosity, and never saying no when I had all these crazy ideas that I wanted to pursue. And yeah, I'll just give that a moment while I wait for a few more people to join on. We have a few attendees. Hello, good morning, everyone. Thank you to the media guests for being awake at 6:15 a.m. The ones that are in London, thank you for joining. I'm just going to head and get started. We're just waiting for one more panelist because we're joining us. Oh, Mr. B, you're here. Just being into the stage. 1 moment. Alrighty. I'm just going to do a quick introduction to the panel, and then I will be ready to get started asking you both some questions. So, welcome everyone to today's panel session. The title is How to Raise a Robot. So in this session, we want to be diving into the fascinating world of social robotics, delving into the intricacies of human-robot interaction and the latest developments in the field, and a little bit about the challenges and opportunities that come with integrating robotics into our daily lives. So we have two esteemed panelists with us today, each bringing a wealth of expertise from academia, industry, education, and they'll be guiding us through what it takes to raise a robot. One that can think independently, interact with emotional intelligence, and ultimately coexist with us in meaningful ways. So let's embark on this journey to understand the future of social robotics and its profound impact on our society. Great. So I would like to first welcome Dr. Thilina. Thank you for joining us. I wouldn't mind if you just introduce yourself a little bit and what you do.
Yeah, thanks a lot, Kameron. First of all, I would like to thank you for organizing this wonderful event and also inviting me to this very interesting and I think timely panel discussion. Yes, I'm an assistant professor or lecturer in Queen Mary University of London, specializing in robotics and mechatronics. In my lab, I call a multimodal human-robot interaction lab. We do research on multimodal sensing, multimodal feedback generation for robots, specifically aiming for developing medical robots. And then also we are interested in soft robotics, how we can use soft materials and soft techniques or soft materials to develop robots. For example, medical applications again. And then I'm also interested in brain-machine interface, which I did my PhD on. So we are trying to use brain signals to control robots. That's about my lab. And then a bit about my prior background. So before I joined Queen Mary, I worked as a research fellow in Cambridge in the Bioinspired Robotics Lab. And then also another 3 years in Imperial College London as a postdoc in a lab called Mobile Electrical Computation, or we simply call MOF I think that's my kind of very brief introduction.
Well, thank you for that. We'll be diving more into your research, especially in the soft robotics and the brain-machine interface. I find that really fascinating for social robotics. I'm going to move on now to Mr. Darren Burchall, Mr. B, as some will say, for the Floridians. So, Mr. B, if you could just introduce yourself so that people know who you are and a little bit about what you do.
Good morning. I'm really proud of you, Kameron, for organizing this. I know in the background you probably have an alarm going off. That was for me to feed my cats. So that's like having a social robot to wake me up to go and feed my cats. I'm not an engineer. I'm a school teacher. I took a year off from teaching because I just wanted a break to do some other things. I get a house sorted out and help my brother finish his house. But in the classroom, I use robots a lot to help children to basically program. I use them to help me in preparation of my of my curriculum. I think a lot of times when we think of robots, we think of this humanoid walking around, robotically. But I think we need to understand as young people, I'm speaking specifically to young people, they can use robots to help them develop their learning ways. I think teachers can use them as alternatives to learning to help improve learning for young people. I think they should be used in several different ways in the classroom to engage young people and to get them into their studies.
Definitely. So just as a quick little housekeeping, for those of us that are listening, if you have any questions, feel free to drop them in the chat at any time into the Q&A section, if you have any questions, and then we can get those answered just at the end of the panel. And then at the last 15 minutes, we'll be giving you guys some time to actually unmute and ask some questions if you like. But you're shy, don't worry. I have a little bit of questions planned behind the scenes. Okay, so let us hop right in. I wanted to ask, actually, for Dr. Thilina, if you wouldn't mind explaining, so what is the difference, would you say, between traditional robotics, like what we have in mind in terms of industrial type robots, and then the social robot? How would you explain the difference between those two?
Well, yeah, I mean, that's like a unique question. I mean, good question. Yeah, I mean, when it's come to like robots, I mean, as per se, like, if you think of like, a few decades back, or maybe let's say 50, 60 years back, when you think of robots, it's like huge, very, very, in terms of size, they were like quite big, and they were not really safe to be work with humans. I mean, if you just Google like disasters with robots, I mean, there are like a lot of casualties when you're using robots. But nowadays we have to work with robots, right? So how do you really work with robots? Because we have to like co-work with robots. So sometimes we call these robots cobots, like collaborative robots. So because we need to work with these robots as a companion. So that's how social robot kind of field come into play. So in my I mean, there could be like various definitions. By my opinion is that like social robot is actually a robot which interact with humans in a socially interactive way, because we humans interact with each other in a different way. For example, like in this panel discussion, I talk, and then audience can listen using my vocal expression, but also I express my emotion using my facial expression, and then hand gestures, all sort of different social, interactions. So when we come to social robots also, show these behaviors, actions, and then also they can perceive human social, signals. Like social robots should be able to understand humans, social, feedback, such as facial expression, vocal expressions, or even touch. And then also they should be able to express the outputs using socially interactive ways, such as using facial expression, vocal expression, etc. So whatever the robot which can interact with humans in a social way, I kind of define them as like social robots. That's my kind of very simple definition.
And then to kind of build on top of that, so a lot of the robotics that you work on is more of a soft kind of robotics. So I feel like that's kind of the thought that we have when you're working with a person. You want to have something that's, I guess, easy to work with in the way that if you're holding it, it's not going to hurt you. It's not going to be sharp or anything. So could you talk about maybe a little bit more about the soft robotics aspect when it comes to social robotics?
Yeah, I mean, I'm asking me, or
I'd say yeah.
No, I mean, yeah. So, I mean, yeah. So, yeah, because as I said, like in the past, like robots were like quite heavy, and then they were mainly made out of like rigid components, like huge motors, huge actuators, metal pieces, aluminum pieces everywhere. But nowadays, we were trying to build the robots using soft materials. Why? Because, for example, it'd be human. We are not really rigid, right? I mean, of course, we have bones, but then we have these soft, skin, flesh, muscles. All these are, soft materials. And then also we have really high level of compliance, for example, high dexterity to do a lot of things, day-to-day activities or activities of daily living. So we don't have these capabilities nowadays in robots. I mean, even if you think of like the most sophisticated humanoid robots in the world, I mean, you may have seen like a lot of really fancy videos nowadays. I mean, companies come up with humanoid robots, but we don't have any humanoid robot which is actually on par with human capabilities, at least now, right? So why? Because we don't have this, softness of these rigid robots. So that's why I think we are kind of moving to soft robotics to see if like we can build robots using soft materials and then in a different, approach. Yeah.
And then I wanted to go back a little bit more to continue with you, Dr. Eden, or Mr. B, I'm coming back to you, but just a little
That's
bit more.
okay. No, I'm listening and learning.
Sorry, I think I hijacked you. Sorry about that. I thought like it was same for me.
No, I'm still asking you, but I wanted to ask you a little bit more about the research that you were doing in terms of, so you mentioned a little bit about the having robots be able to express themselves, especially when they're more social. So if you're using them in the capacity of humans, you want them to be able to express different things. So we can understand, like the way we're talking now, like you see hands, the way we're looking at each other. So some of the robotics that you were looking at, I think one of the papers was about vocal pain expression for a robo patient. So could you first explain what is a robo patient for the people that don't know? And then why is it so important to be able to look at how they are expressing that form of pain when they're being used in healthcare?
Yeah, actually this robo patient term, actually came from my previous, project that I was involved with in Imperial College London and also at Cambridge. So my supervisors previously, they had this grant from UKRI, United Kingdom Research Innovation Institute, to develop a robotic patient to train medical students in specific examination called abdominal palpation. So I don't know whether you know about abdominal palpation. For example, if I give you a bit of context about this, let's say if you are having a pain in your abdomen, and then when you usually go to a doctor like GP in UK, so they start palpating your abdomen to kind of diagnose the issues like many abnormalities, and then when they do this examination, they specifically do this examination called palpation, where they try to press the abdomen like it's slightly palpate. And then they look for different cues. Like one of the cues is like actually facial expression, because let's say if one of you have, like, let's say some issues in somewhere, when it is like pain, and then when someone press, you feel pain, right? So we can kind of detect that using facial. Doctors can detect that using facial expression, but also they tend to make noises like pain sounds. So in this particular project, we were trying to like develop a robotic patient to kind of mimic these expression. Like let's say we have a phantom to kind of simulate that abdomen, and that when someone palpate on this abdomen, we try to generate this facial expression using a robot, and then pain expression also using a robot. Why? Because one of the issues we found in literature is that the biases, for example. That is one of the key aspects that I was looking at during that project. So because I was mainly focused on my research in facial expression. Why? Because country like UK, especially like space like London, so we have people from all sort of different background, and then to identify or distinguish pain expression, facial expression is quite tricky if you don't have experience. For example, I'm originally from South Asia. Let's say, just imagine that I come to, let's say, a Western country where like predominantly white population, and then if I'm being a doctor, and then if I get a white patient, and then if I can't understand the facial expression, it's not good, because I might kind of bias, right? Like, of course, most of us can kind of, identify different facial expression, but people are different because people are so subjective. And if you don't have experience, it's quite difficult even for a doctor to kind of, recognize this different facial expression. So because of that, we thought of developing this robotic patient with different facial expression to train medical students. Because, for example, in that project, we developed a robotic face where it can mimic different facial expression from Asian male to Asian female, black female, black male, or white male, white female. So we can synthesize these different facial expressions, and we expose these facial expression to the medical students. And then that actually accelerates their learning, because you don't need to wait until you get such a patient, right? So that's about the whole project. But then in this particular paper that you mentioned, the vocal expression, so we went a bit step ahead, and then we tried to synthesize vocal expression assay, because when someone expresses painful area, though you tend to express vocal expressions like So how do you really model this? That was the question. So it was actually one of my undergraduate students' work. When I was in Cambridge, I supervised that girl. So she did a nice study to kind of model this. So so that's about that paper, that study.
I think I really like what you said about how if you don't have that experience in that training, it definitely leads to bias, especially in the medical field. That's such a problem. And it's good to know that at least people are working on it to give you that experience. I think that also ties quite into what you do, Mr. B, with your education side. So looking at how you're using robots to help educate students in the classroom. So you touched on it before, but if you wouldn't mind diving a little bit more into how you're able to use your robots to help your students with learning and to give them that experience.
For me, right, I was living and working in China. I'm going to preempt what I said by saying I was going to a conference. I was head of a department. I was taking one of my colleagues to another part of China, and we went to the airport, and my colleague smoked, and when we went through, gave the boarding pass, and went through a gate, not to enter the plane, but to enter the actual airport area where only passengers can go. A robot, Mr. Soft Robot, came up to my friend. We were walking together and came up to him and asked him for his lighter. So we looked at each other really strange. So we put it in his pocket and gave him his lighter. Went to the conference. When we came back and at the exit, the same robot, for some reason, China's magnificent when it comes to this type of technology. It picked him up through the facial recognition, and a robot came up to him, and it wasn't talking. It was like a 9-inch iPad type of screen was his face, and I communicated and was telling my friend, he had a tray, "Thank you for giving us your lighter. You can have your lighter back." You understand? So right away we started thinking, how can we bring this type of stuff into the classroom? Obviously, the curriculum's not massive enough for us to just build robots that have this type of technology. So what we decided to do was to use a lot more Arduino type robotics. When I say that now, I've been using Arduinos and micro processors for some time in the classroom and just building basic robots. One of my most popular ones is a car chassis robot that I make sure children can build. It gives them some engineering tasks. And then we put different types of sensors on it, line sensors and sonic sensors so they can see distance. And it sort of operates like there's vacuum cleaners that you just push a button and it just vacuums your house. So we turned to that and we developed curriculum for that. And out of that came so many other different transferable skills. So for me, it's the collaboration and building and designing these type of things. For me, is forcing children to not give up on what they're doing. Because even at the lowest level, when you're programming and building and designing, this stuff doesn't go right the first time. As you would know personally, Cam, I remember when you was a part of the Bermuda team that represented Bermuda. And I remember you looking at me and discuss, Mr. B, I can't do this, and it makes you go through that boundary and breaks down those barriers. That's why I think robotics is so fantastic. Of course, I'm going to call you Dr. T because I'm going to really match your name up, Dr. Thilina. It's easier to say that. So I'm at the other end of the spectrum. So, and it's really, I'm sitting there in awe thinking, wow, I begin it and he ends it. And it's all that happens in between there for young people to learn to get to that. So for me, that's why robotics are important to me. It's important as a primary and secondary school teacher to know what the next step is for my students who go into robotics and because it's a massive world is computer science, and I like to use it primarily to build transferable skills. And for me, in education, that is what the robotics is all about. When I get young people on Scratch and get them to create their first 10 lines of code to make that cat walk around in a circle and say meow, and if there's a no about Scratch, that is the beginning of it. So for me, that it is to spark that imagination and to spark that there's transferable skills that they can take to other subject areas and even take outside of the classroom and go further and beyond. So that's where it is for me.
I remember those little robot cards as well. Learning how to use those was definitely one of the first times I started learning about the robotics, and then Scratch as well. So just looking at, I think it's very important, like you said, to show students how, those little exercises that you're doing when you're first learning how to program, and then building up to what Dr. Thilina is working on with like healthcare and looking at how you can use social robotics in that aspect. I don't think we show them how to connect the dots that often, which is why I wanted to bring you both onto this panel to show how you can go from learning in the classroom into more of an industrial or research-based robotics. And actually, sorry, I'll let you keep going.
I can remember I did a task with all of my classes. I actually did it with one of my classes, no matter if there's IB, IGCSE, or if they were doing just the national curriculum. So I did a task and just wanted to see it. And I asked students to go away and to create a presentation. They can use anything to come back with how robots are used out in the society, how social. They didn't know that they were studying social robots. You know what I mean? And the presentation that came back, they were actually in awe that, they use robots. A doctor could be here in Bermuda doing a surgery over in the UK, using robotics and using the AI, using this type of technology. And I think it was fantastic for them to actually see what the final product is and how these robots are used, how they're used in industry. We always see commercials, car commercials. Sometimes they take you into a factory and you see the robots. You see a robotic arm spraying the car or putting the car together, and it goes down a conveyor belt. So it was fantastic for young people to see that, because they didn't make these connections. And as you said, it's so important that they can see the dots can be connected.
And then just to bring it back a little bit more into so the title of the panel, for those who don't remember, is How to Raise a Robot. So I wanted to talk about how in social robotics, so Dr. Salim, you might have a bit more insights into this, but looking at how when you're training these robots, it's a little bit like when you're raising a child. So you have to just kind of make sure you're telling them what to do, and then you give them that direction. So if you could explain a little bit more about if maybe you've used a similar methodology, or what kind of like mindset you have when you're teaching your robots what to do, like how you look at these AI models that you're using.
That's also a really good question. That's really interesting, thoughts, because yes, we need to raise sometime robot as like a kid, right? Of course, we don't have such intelligence at the moment. We talk about all these, new modern, machine learning techniques, ChatGPTs, all these large language models, but still they are not actually in the level of human intelligence. So these companies, massive companies, and scientists are racing towards developing AGI or general intelligence, artificial general intelligence, which is very equivalent to human intelligence, but we are not there. I think it takes ages to do this. So when it comes to robots, at least I can talk about some of my approaches. Like, for example, when we wanted to develop these medical simulators or mannequins or mannequin robots or robotic patients, so we actually use different techniques. Of course, one of the main component is actually hardware, because hardware is like a physical component, which is quite tricky to develop, because it's quite difficult to kind of replicate or mimic a human in a robot, because as I said, we consist of really sophisticated. One of the engineering marvels, right? So we have these sophisticated face with like lot of muscles to kind of represent facial expression, etc. And then we have really fantastic, fascinating skin, kind of a huge sensor all over the body. So it's really challenging to replicate this within a robot. So what we are trying to do is try to address these different challenges step by step. In some of our previous works, we try to develop light skins or maybe sensors using soft materials to kind of mimic it, because soft materials are like, let's say, for example, silicon rubber. We use like silicon rubber to like represent, kind of mimic abdomen, because we can actually get these physical properties really match to the abdomen using silicon materials. So that's one thing that we looked at before. And then also in terms of raising like intelligence, for example, what we did in some of our experiments, some of our studies, we actually took a data-driven approach. For example, let's say pain. I simply take this this example that you mentioned before, pain expressions. So how do you really model the pain expression of a human express pain when someone palpate on that person's body? It's quite difficult, right? Quite challenging. So what we did, actually, we used a data-driven model. So we took an assumption at the beginning. We assume that the pain is, let's say, R or E, like that. And then we ask question from the participants whether you really like that pain or not, or maybe like whether you really like it, agree or disagree, strongly and disagree. We actually use this kind of a user-driven approach or human-driven approach, and then we get the feedback, and then using that, we try to model that relationship between palpation and then pain. So this is one approach that we use. So data-driven approach with a combination of machine learning. For example, at the moment we are running an experiment. I mean, there's a collaborative project between Queen Mary and Cambridge. So we are trying to use a method called reinforcement learning. I don't know whether you heard about it. Probably you might have heard about that technique. So we use that kind of a deep learning or machine learning technique to kind of model this relationship, because modeling this relationship using mathematical ways is quite challenging, because we don't have mathematical models at the moment to kind of, for example, in physics world, I mean, in physics domain, I mean, there are like simple relationships. Of course, we like to have simple relationship, but it's quite challenging because this involves human behavior, this involves psychology, psychophysics, it's a multidisciplinary problem. So because of that, we are trying to approach a different way. One of the ways, machine learning based, human studies, human behavior studies. So those are the current techniques that I'm using within my group.
And then if you could just briefly, really quick, Mr. B, if you could just briefly explain what is reinforcement learning, just for the students that may not know, just if you could just explain it in a quick like that, I think, just in case.
Yeah, so reinforcement learning is like one of the deep learning methods. So like learning, I mean, so we have machine learning, and then the machine learning is like how we generate, how basically we train something using kind of program. I mean, in a simple scale, it's like a training way of how we train a relationship between input and output, right? So we have different techniques like within the machine learning, deep learning. We have neural network, deep learning, reinforcement learning. Yes, when it's come to reinforcement learning, so very simply, if I say it's a kind of a reward-based learning. So just like how kid learn, like to learn how to walk, right? I mean, I will very simply, if I take example, like, I mean, when you're a kid or when you're like a child, I mean, we try to walk, right? But we don't really fall for like million times. It's just like 1 or 2 times, and we quickly learn, right? From the feedback, because whenever you fall, and then like you learn, oh, maybe if I walk that way, probably I will fall again. So you learn quickly. So it's like a reward. So if you learn, how to walk, and then probably you can reach to maybe your mom or with dad, or maybe if there's some food, maybe you can go there and take that, right? So it's like a reward-based method. So my take is that like, it's a reward-based learning. There's a reward, and then they try to learn that from the feedback. Yeah, simple terms. Of course, there are like the complex definitions. But yeah.
Very fascinating. That was just in case people missed out on what that one was. So I wanted to take a little bit more into back to the education side. So we think we brushed on it briefly. So we've been talking about the different ways that you can learn and using these in the classroom. But I'm not sure who would be the best person to ask about this one. But when you're using these robots in the classroom, for example, to assist in education and even like giving them social skills, So what ways do you think we can use social robotics for those students that maybe have like learning disabilities or maybe just having different paces of learning in the classroom? So what aspect of maybe Mr. B, you might be the person to act about this one. How do you feel about using social robotics for that category?
I think it's absolutely brilliant. It's vital, because I think one of the few areas in education at the adolescent age where you see highly and gifted and talented people actually work alongside with less able students or additional needs students. I think robotics allows those two to marry together. It's nothing better. What I used to specifically do, and my students didn't know that's what I do, is I would put a gifted child with an additional needs student and let them feed off each other, because these types of students, different groups of students, have different skill sets. Some will go up with their hands, like usually additional needs students will go up with their hands and they express themselves better by creating and making. So when the gifted and talented students operate, I shouldn't say better, but more efficiently in a higher level thinking area. So when the minds are at work. But what's really good is when you use robotics and marry these two skills together, it helps develop, it aids the additional needs student, because they actually get positive outcomes, to the task that they're doing. And the additional needs student, it is there because they sometimes take up the role of being a mentor or a teacher, you know what I mean, and help it. So I think it is absolutely vital that we use robotics and we marry those two the groups of students together. I think it's important for teachers to understand exactly what their students are capable of and use the robotics to allow them to build and develop. I'm so glad that Dr. T spoke about reinforcement learning and supervised learning, unsupervised learning, because there's some things in the curriculum that I go into really deep, and the young people don't get it right away, especially when we talk about the algorithms and what are used in these two specific areas, especially recommender systems. I'm just going to blow off the top of the end on this. I ordered a pair of sneakers off of, I don't know, it was TikTok or Facebook the other day. And now it was Facebook. Now when I open up Facebook, all I see is people trying to sell me stuff. And students always say, how come when I turn on my Netflix, it knows what I want to watch? It recommends stuff to me. That's recommender systems. And this is an area of robotics. And that, like Dr. T, I spoke about reinforcement learning and robots learn and they develop their minds, robots, by experience and being rewarded, And I think it's important that we understand that. And when I'm in the classroom and using these robots and explaining these things with young people, they get to experience it and play with it. They're actually learning higher level robotic stuff at the primary and secondary school level, which I think is very important to set their seeds. I think that answers your question.
It does. And then to kind of go into a little bit more, I think we might have touched on it earlier. So looking at, I think it also comes from when you're using these things in the classroom. You even mentioned like these robots having a mind or being able to support students in that way, especially from a teacher's perspective, when you have that emotional connection with your students, especially when you're learning. So how important do you think it is for robots to be able to have that emotional connection or that emotional intelligence? And I think I'll ask you, Dr. Thilina, what you think first, and we'll come back to you, Mr. B, about having this emotional intelligence in social robotics.
Yeah, I mean, that's a tricky question because, I mean, there are a lot of, arguments and then, debates about the emotional intelligence because, yes, of course, we have really intelligent systems, but then are they really emotionally intelligent? Like, or whether they have simple question, whether these robots have consciousness, right? Yeah. So we as humans, we are conscious. We are smart, right? I mean, we are smart, and then it's a different type of intelligence. So I think that's why I said even though we came long way to, demonstrate this really sophisticated, really high end, artificial intelligence, but still we are not there. So yeah, when it's come to emotional intelligence, I think Yeah, I mean, personally, I would like to have like, more emotional intelligence in robots, but I think it's a really challenging problem to solve. Of course, I think we can try. I mean, I'm sure, like, I'm pretty sure, like, there are a lot of groups in the world, I mean, actually trying to make these robots emotionally intelligent, in different ways. For example, one of the main areas is like facial expression, which is one of my main areas as well. So because we try to make the emotional intelligence, of course, you have to have intelligence, but then you have to express these emotions. So how do you really express these emotions? One of the very powerful ways, like facial expression. But then if you look at the current robots in the field, I mean, there are like a couple of robots. For example, one of the very good example is Ameka in, I think, engineering arts from UK. So they have probably, I think, in my opinion, one of the best, robots with facial expression, like almost like human-like facial expression. But still, it's a very tricky area because when you see a robot with like a human-like shape, we as humans, we are expecting these robots to work or behave as humans. That's the simple truth. Like, let's say if I have a robot with like a face, and you are expecting this robot to behave as a robot, behave as a human, but we are not there. So because of that's it's quite difficult to kind of get this emotional intelligence and interaction between robots. Because some people think that they're kind of, that's eerie. I mean, like, so it's like quite tricky. So that's why we talk about this uncanny valley, because if it's too similar to human, people think that it's really uncanny. I mean, so they think, this is like very scary. But some people, they like it. So it's a really fine balance between all of these. So when it comes to emotional intelligence, I think we have a lot of things to do. But yeah, I mean, facial expression is one thing, mobile expression, and then also intelligence, like to say, like, I mean, how we can really program these robots in an emotional way to kind of react with the people. But this is quite a challenging area. Yeah, I mean, I think people are, I mean, groups are making progress.
And then I wanted to go back because we kind of touched on this earlier as well. But looking at the sensors that you mentioned before, so you and your research are looking at multimodal sensors. But for my undergraduate research, it's a tiny little sensor in comparison to the work that you've done. But if you wouldn't mind explaining what is a multimodal sensor, like what is that area? And then also if you could talk about how it assists especially in the social robotics aspect.
Yeah, I mean, so we talk about social interaction, right? So when it comes to human, like there are like, I think at least like 5 basic sensing modalities. Vision is like from your eyes, and then vocal expression, or like you can hear from your ears, and then taste, and then smell, and then touch. I mean, these are like main 5, right? So when you take one of these, that's one sensing modality, and then if you think of all, it's a multimodality. So whenever you have like several types of sensors, sensing modalities, we kind of simply call them as a multimodality sensing. So this is really important for social robots, as I said, because if you want to create or if you want to develop a robot can actually socially interact, which means that that robot should be able to perceive or understand the different social cues, right? So these social cues include facial expression, vocal expression, hand gestures, or maybe touch. Let's say when you shake hand, how do you really feel this interaction? Touches could be smells, could be taste. So these multimodality or multimodal sensing should be there in social robots to kind of really react in a socially interactive way. So that's about social sensing. Multimodal sensing, and that's why we need multimodal sensing in social robots.
And then so you touched on a little bit, like for example, shaking hands. So I'm going to take it a little bit into that back. I want to go back into the design of these different robots. So you talked about the uncanny valley, like not wanting it to be too close to what we look like. But I wanted to ask, so when you're using these robots, especially when you're introducing them to people, I feel like that design aspect is really important. So like what it actually looks like. And we talked about the facial expressions and how they're able to react to different people. A lot of the robots I've seen that are social are more, I guess, animalistic in their design, because that's kind of the comfort zone that we have. Like you picture a social robot, you picture like C3PO or like R2D2 rolling up to you. That's what you expect.
Yes.
So, could you talk a little bit more about, I guess, that design of the robots and how important that is in terms of social robotics?
Yeah, so that is also a really, really good question because, yes, as you said, like when it comes to social robots, and there's a very broad spectrum. There are like really abstract robot, like, just take a simple animation, like a cartoon, right? I don't know whether you have seen this cartoon called Tintin, which was very famous. I don't know whether you know that. So, let's take like a simple cartoon. Like the face is like, tiny, like two lines to represent the eye, and then like one tiny line to represent nose, and then maybe circle to represent mouth, right? But then you can express a lot of things using this simple cartoon. Just like emojis, right? When you chat, you use emojis. But these are not really sophisticated, face or anything, right? It's just like a couple of lines. But still we can express, different social cues. Like let's say if you're happy, you have this, and sad, maybe smile. So very simply, you can represent these. So these are actually like really abstract kind of social, I would say, like social agents or robots. Could be physical agent, like a robot, or it could be virtual. It could be like a virtual character. But then you have like other end of the spectrum where like really human-like robots, right? So depends on the spectrum of the robot. So we use different techniques to develop robots, like in terms of design. Let's say if it is like a really sophisticated robot, you need to really mimic all these different social cues, like really complex socialization for that. But then the drawback is that you have to have a lot of actuators, a lot of degrees of freedom. Lot of actuators means like a lot of motors to kind of move the muscles, etc. But then when it's come to like really, very abstract, let's say just iPad face with like animation. So you don't need like motors, right? You don't need to have motors to kind of actuate a robot's teeth. So I think it depends on the level of abstraction. So the complexity of the robot design increases, and then also the intelligence side of the robot also increase because let's say if you want to show a really human-like face or a body, like gestures, you have to have some sort of intelligence. You need to get this acquire this feedback from the environment, and then you need to react. You need to generate this feedback. So that's I think. It depends on the level of abstraction, in my opinion. So if it is like really abstract, you don't need like a lot of heavy design. It could be anything. It could be like a simple ball, and then the ball moves here and there, right? That also is a robot because it's interact with the person. But then let's say if you have a robot with hands or like fingers in your face, so that's a really complex system, and then you need like complex design.
I think it's fascinating that now that we're talking about these robots with the sensors, it's almost like they can, like you're giving them the same kind of senses that we have, or we're trying to mimic that. And that can be a bit weird for some people, like when like if a robot can do like the face tracking, for example, that some social robots can do, or you pet them on the head, they feel it and they kind of move around. So it's just fascinating to think about the ways that they're able to start expressing, especially within these designs that we give them. Like you mentioned, the iPad face and things. I just find that really fascinating. So I wanted to bring it back to you, Mr. B. So looking at, I guess, like we mentioned, like this kind of uncanny or uncomfortable feeling that people have when you start bringing in social robots to our day-to-day lives. I think students might be a bit, like children might be a bit more accepting because, they haven't grown up not seeing all of these things. So it's just kind of integrated easily. How would you say, just as a final question before I let everybody start unmuting, but how would you say that students, and maybe even a little bit about the parents, when you try to bring in these robots into the classroom, what is their reaction to the robots?
I think the first reaction is, these robots are going to take all of our jobs. That's what comes from the adults. Where the young people are like, cool. I might have a different type of job from you. I don't have to. I have more options. I think one of the most important things is to understand. And I try to get young people to understand, and even when I have parent conferences and I'm confronted with these questions, is that it's a whole new field. So it's going to allow opportunities for young people now to go in other directions, to go into other areas. What I always tell people, don't worry, we're still going to need certain skills in the world. We're still going to need certain workforces, but this is going to opening up a whole different field of opportunities for young people. I mean, I got grandchildren, and my grandchildren are, one of them's 10 years old. My grandson just ran 5, did their cup match. And the type of work he's going to do hasn't even been created yet. You understand? So his future hasn't been created, but we know that as we go further down the road with robots, that more and more opportunities for learning and for employment and careers are going to come out of robotics.
So just because it's coming to the 15-minute question kind of panel, part of the panel, I should say. So if any of the attendees, this is your chance that I wanted you guys to be able to kind of unmute and also connect with some of the speakers. So we've talked about, the different ways that you can get robots to express themselves. They've told you a little bit about their own backgrounds. So for example, Dr. Thilina is one of the assistant lecturers at Kameron, who's also my supervisor for undergrad. So he has quite a lot of experience to talk to you about. We have Mr. B, Mr. Burchall. We can talk to you more about the education side of robotics and looking at how you can start bringing it into the class. Maybe even you can start convincing your teacher to let you have a robot in the class.
I'm a robot for a teacher.
Exactly. You never know, a robot teacher one day. So if you have any questions, or if you'd like to get the opportunity to kind of network with these two, feel free to raise your hand. If you're shy, don't worry. I have some questions to get us warmed up. But if you would like to talk to them, just raise your hand and I'll unmute you and you can have a chance to speak with them. Just let me know. But in the meantime, I'm going to go back to some of my other little questions. So I think one of the other things that's really important with social robotics is looking at, this one moment. So looking at that, that language processing side of things. So when you're if you're speaking to a robot, so I feel like when you see a robot, you automatically ask it things. For example, with Siri and Alexa, people got used to that quite quickly, being able to say, "Hey Alexa," or "Hey Siri, what can you do this for me?" So just if we could talk a little bit more about how people interact, so that human robot interaction a little bit more. So how people are able to speak with the robots or just kind of use them in their day-to-day lives. If anybody has a little bit more that they can dive into, but that human-robot interaction, I think is really interesting. Dr. Thilina, I could start off to bring you in.
Yeah.
I'm sorry.
No, go ahead. Yeah.
No, after you. No,
that's fine. So go ahead.
Oh, yeah. So, human interacting with robots. When you travel now, you go to a machine and you put your passport in and you get your boarding pass. Even cleaning the house, have a little robot that goes around and helps me. My wife's going away, so I went and got one because it's easier, to clean it. So we interact with robots in so many different ways. I think we always have that idea of a humanoid, when it comes to robots. And I think what Dr. Thilina spoke about earlier about depending on the abstraction and when we're using, how we're using, what is appropriate and what is inappropriate. But I think as we interact more with robots, it's going to we're going to get more comfortable. I think, like I spoke about my grandchild earlier. Let's say primary 1 students and primary 2 students. I honestly believe that they're going to work and live with humanoid robots. They're going to be walking down the street, or parts of the world now where you get a taxi, you just order the taxi, a car comes and you jump in and it takes you where you're going. There's no one driving. You understand? So we're interacting with them and we're already going down that route. It's just a matter of how far and how fast we can get as far as it goes. I think for me that is the understanding and the mindset that we need to have.
Yeah, that's totally true. These robots doesn't have to be humanoid shape. Could be anything, right? Because when it's come to human-robot interaction, you basically interact with the machine. So yeah, we can call it like a robot. It could be a simple ball, as I said, move here and there. So we can define it as a robot because it has sensors, it has actuators, it has some sort of a processing system, just like how human works. So we have sensors to hear, listen, and then to hear, and then see, and then also we can have a brain to we have the brain to process, and then we have actuators muscles, and then do these different things. the same way, I mean, could be a simple ball, right? Ball type robot where like can move, here and there. It's, based on the sensing, feedback, and then it has a tiny processor to kind of process, and then we have to move, and then there are like set of motors to like move. So these are like actually, any system which has this sensor, it has some sensors, some processing unit, and then actuators. We kind of simply classify them as robots, and then we have such machines everywhere, right? I mean, so when you say human-robot interaction, I think it's just not like interact with social robot. I mean, like human-like social robot. It could be anything. So it could be a medical robot where like it try to, doctors are used to like, do the surgery. It could be that, or it could be a teleoperated robot. It could be a, human robot as you mentioned. Or it could be a simple mobile robot where you simply control using remote. Like, we have all these type of robots in space exploration. Like, for example, we send like quite a lot of robots to Mars, Moon, to kind of explore the different planets. I mean, these are also robots. And then, of course, they are not really interact with humans face to face, but still they are interacting, right? Using joysticks or whatever the way. So, so you can kind of distinguish these interaction into different forms. I mean, some of them are face to face, some of them are like, teleoperated. So in my opinion, I mean, we can see, I mean, almost all the robots in the world, I think you can kind of classify them as like human-robot interactive robots.
I think you briefly just mentioned a little bit about different ways that you're able to control the robots as well. I think that would be a great segue to kind of introduce students to a bit of your research with the EEG control, looking at the brain-machine interface, just because I want to give them that exposure. If you wouldn't mind explaining a little bit about what that is and how you're able to use your brain. So this is what's pretty cool, guys. You can use your mind to control some robots. If you could talk a little bit more about that as well,
yes.
We would love to hear that.
Yeah. All right. So that I started this work because I did my PhD in brain-computer interface when I was in Japan. So I tried to use brain signals to control robots, not really robots, like devices, like processors. These are like artificial arms to support, amputees, for example, like an artificial robot to kind of, help with the amputee to grab something. So one of the main aspects of this area is that like how you really, get these signals to control, because for amputee, let's say a person who does not have two arms or two limbs. So how do you make a robot like an artificial arm? Yes, you can make a robotic hand or maybe robotic or hardware hand. But then how do you really control this? Because that's a quite challenging problem. Because human brains actually controls everything, but then you have to somehow get these signals to control this robot. So that's where this brain-machine computer interface come into play. So where we can record the brain signals in different ways. In my research, I mainly use a technique called EEG, which is a surface, electrode system. So where we wear a cap, and then we record these tiny electrical signals from the brain, and then we try to decode those signals to control different robots, including processors. So that's what we in simple term we call brain-computer interface. So brain interface with the computer, interface with the machine. So sometimes we call brain-machine interface as well. So in my research, I try to use brain signals to control robots. I have a master student actually who are working on this brain-computer interface area. So he's trying to control a meal assistant robot, like it's a meal feeding robot for a disabled person, aiming for a disabled person. So that person, whenever the person wear this cap, he or she can use brain signals, his brain signals to control this robot to kind of feed. Let's say if you want to eat something, maybe you have to have like some sort of food, maybe lay on the table. But then when you think, and then robots actually decode that emotion from the brain signals, and then robots actually scoop and then feed. So that's a very simple research that I'm working on with one of my students. Yeah, it's simply it's all about like how you acquire data from the brain, and then use different techniques, for example, machine learning, and then decode that signal, and then sets into like actuators like motors to kind of control. Yeah.
You say simply, but that is just, it's pretty out of this world and fascinating. It's fascinating. I wanted to take it a little bit more to you, Mr. B, because I went to a conference recently called Viva Tech in Paris, and they were using this kind of, well, it wasn't brain controlled, but just looking at how you can pilot these robots, for example, for rehabilitation. So they were using, it was called Orihime, and they have robot pilots. So people that are not able to leave the house, and then they have a cafe in Japan where the robots are actually taking people's orders and writing things down. And I was just thinking from earlier, I think we touched briefly on a robot teacher, like this idea that, you would have a teacher, or you would have like a teacher's assistant that could be a robot. So Mr. B, if you could talk a little bit more about what you think about integrating an actual, maybe not a humanoid, of course, I think we're quite far out from that one, but just like even having like Dr. Thilina mentioned, like a little ball or something that could roll around the classroom and answer students' questions when the teacher is busy. So talking about, I guess, that real final integration of robotics into the classrooms, actually having a physical one there.
Yeah, I think it started, that November 2 years ago when ChatGPT exploded on the scene. A lot of my colleagues, I did a little seminar at school, or some training with some teachers, and I showed them how quick it is to make a schema work. And they sat back and said, "Wow, my summer holiday just finally arrived." So this is the beginning of it. I said, I made a schema work with the resources, with the assessments, with everything in about 30 seconds, and they honestly couldn't believe it. You know what I mean? Then I told it, it's getting better and better. I think we're at version 5 now, 4.5, and the is just getting better and better. So, and this all comes from learning. And we spoke earlier about reinforcement learning and unsupervised learning. With robots just take over the learning of themselves from data. I think I don't see. I think it is already here. Cam, at the lowest level, and some people don't understand it. Like for instance, when you were building those robots at BHS, when we had our STEM academies, quite often, and I think at one point you became a teacher. You was helping me do it, and we had all these little ones. Can you help me, Miss Cam? Can you help me, Mr. B? And Mr. B was helping little Billy when little Mike wanted help and little Angela wanted help. So what did we do? We just gave him a microbit, which was easier. Go and play with this microbit while I take care of the iron stuff. You know what I mean? So and I do that in class. You know what I mean? It's I'm done it. I don't know if I know students who if they're listening. You have your tasks in class, and then if you finish, you get extension tasks. And what do you do when children get extension tasks? I say, get the microbits out. Let me see if you can program something real quick with the rest of your time as a reward. So in a way, I think at the lower level, we do have that, and it's just how we use it. And I like the idea where Dr. T spoke about having the balls and the young people being able to play with them. And when I was teaching, I hate to use name brands because I don't see these companies' name in the background as sponsors. So I used to have boxes of these robotic kids, and I used to tell kids when they, if they got a hand over there, they weren't, even children that weren't engaged and weren't getting concepts. I was like, something, I tell you, look, leave that alone. Go over there and play with that and see if you can build something with that. And that will be your project. And that was like a somewhere to go. So that was like a robotic sort of teaching assistant. You understand? Because, they were building robots and they were playing robotics. So, but I think, like we said, we think teaching assistant or teacher, it doesn't have to be a human. It doesn't have to be a humanoid. It has to take on the shape and the form, like Dr. T spoke about earlier. It has to take on the form what we're using it for, but it has to be purposeful and relevant to what we're doing.
I'm sorry to cut you off, Mr. B, but we are unfortunately at time. I'm heartbroken because, this is over. It was getting good.
Let's go further. Let's count something.
But I wanted to invite everybody back for session 2. We're like at my little sketch. Sorry. So we will have a session later in the day where you can actually speak with a robot. So he is a humanoid. His name is Captcha. He's quite sarcastic. If you ask him questions like, what's your favorite thing to do? He'll tell you it's make fun of humans. So if you're excited about that one, you can join on again at 2 p.m. Bermuda time, which is going to be, I believe, 6 o'clock UK time. That's a little Q&A session where you guys can actually speak with a robot. So we can talk to one of the social robots that's actually live. Our next session is going to be at 8:30 a.m. Bermuda time. So we have about just under an hour before the next one. So that's on ethics and bias in AI. So we have Hannah Klaus and Cara Morton that'll be coming on to speak with us. And so, yeah. And then also in the evening, we have AI questions that your employer will want some answers to. So if you have any questions about like getting an AI internship, perhaps, then we'll have Treefall Consulting giving us a little bit of a workshop on how you can bring AI into the workplace and also in your studies. And safely, of course, obviously, safely bring AI into your studies. So thank you both for joining me. I really enjoyed speaking with you, and I hope the students that were listening. Thank you both to the two students that stayed behind. Thank you for listening to the rest of the panel.
Thank you, Kameron.
And enjoy the rest of your day. Thank you.
Bye-bye.